A laser pointer at point S, which we can see on the diagram, directs a highly focused beam of light towards a mirror. The beam bounces off the mirror at point B and is then reflected away from the mirror towards point R. We can see that along here. The mirror surface is given by this equation, and the laser pointer is positioned here, and the beam is directed in this direction. We want to find the position vector for point B, where the line, the laser line, meets the plane. So if we think about that line, we know it originates at -2, 3, 6 and then goes in the direction 1, 1, -1, and the plane is r dot 0, 1, 2 is equal to 9, and we want the intersection. So this line can be written as -2 plus lambda, 3 plus lambda, and 6 take away lambda. And we just substitute it in here, we're just solving simultaneously. So we've got -2 add lambda, 3 plus lambda, 6 take away lambda, dot 0, 1, 2 is equal to 9. So, well, this is times 0, so it disappears. And then we have 3 plus lambda, which is times 1. And the 6 minus lambda is multiplied by 2, so that's going to give me 12 take away 2 lambda. That's equal to 9. So that gives me 15 take away lambda equals 9, and therefore lambda equals 6. So the position vector of point B, if lambda is 6, is -2 add 6, which is 4, 3 add 6, which is 9, and 6 take away 6, which is 0. Now, for part B, this is a really difficult question actually, and it's a question of going about it the right way. There's all sorts of ways you could go about it that could actually be horrendous, but I think I've found a pretty decent way of going about it. So the laser beam is reflected away from the mirror so that the angle of the incoming beam to the normal of the mirror is equal to the angle of the reflected beam to the normal of the mirror. So if this is our mirror, what we're saying is that there's the normal, and we know that the normal goes in the direction 0, 1, 2, and what we're saying is this angle and this angle are equal. Now we know that this one is coming in the direction 1, 1, -1. Make that a bit clearer. So 1, 1, -1. And so this is coming out here. So they're all contained in one plane. So all three of these lines. And we're going to have d2 hat here, which is the unit vector in the direction of the reflected beam. So d2 hat, so that mod d2 hat is 1, it's a unit vector. We want to determine the unit vector d2. Now, there is quite a good way of doing this, which is not too painful. And that is, if we have this as d2 hat going this way, and consider the vector that way, so it will just be the reverse of this one. So that's going to be -1, -1, 1, and we'd like that to be a unit vector as well, and we'll see why because of the symmetry in a second. Now the magnitude of this is just the square root of 1 squared plus 1 squared plus 1 squared, so √3. So if we say 1 over √3, we've now got a unit vector this way. If you think about this, this is a rhombus. And if this is a rhombus and these angles are equal, it follows that 1 over root 3, negative 1, negative 1, 1, so this vector, added to this one, must be equal to some multiplier of this one. So it's going to be k 0, 1, 2. So that gives me that d2 hat is equal to, bring this over, it's going to be 1 over root 3 for the first component, and then it will be k add 1 over root 3, and then 2k take away 1 over root 3. Now that only leaves us with one variable here, the k. But we know that d2 hat is a unit vector. Therefore, the square root of 1 over root 3 squared plus k plus 1 over root 3 squared plus 2k take away 1 over root 3 squared, we know that's equal to 1, and we can use the calculator to solve that. And indeed, I've already typed that in because I didn't think it would help just let you watch me do that. So we get that, and we see x is 0. We can reject that because the x is 0 situation leaves us with the same vector that we had here, essentially. So this must be the value we want, 0.2309. So k is equal to 0.2309 to 4 decimal places. And that leaves our vector, d2 hat. Now we were supposed to give these correct to 0.01, which means we want decimals. So this one is just 1 over root 3, which I've calculated, and we can see to 2 decimal places that's 0.58. And then for the next one, it's going to be k, which is our 0.2309, add 1 over root 3. Well, that comes to 0.81. And then we've got 2k, so that's 2 times the 0.2309, take away 1 over root 3, and that one there gives me negative 0.12. And that's our vector. That's quite a clever way of doing it, and there are much harder ways of doing it.